Hey everyone, welcome back to another day of robotics. Today, what we're going to do is keep on working on the functions to control the wheels so that we can do complex motions with our car here. Now, before we get into that, I need to apologize to everyone because I had you wire the motors to the driver in a way that it worked well when we just wanted to go full speed or stop, but when we wanted to go half speed or in between speed, it would only work at times, or only on one motor, or only on one direction. And it was an oversight. It was actually you guys and Mr. Ramos had reached out and said, maybe there's something we could do on the pins. And so let me just cover that so that we can fix that on the video. Even if you've already fixed it, I think it's good just to like see it on the video and have me explain what's going on here, and then we can move on from there. All right, so I'm going to share this diagram. All right, so this is how we initially wired it, right? So we have motor A is to 12 and 10, and then motor B is to 11 and 8, okay? And you see there are these squiggly lines or tildes, okay, on only some of the numbers. So 11, 10, 9, and 3. And if you look at the Arduino board, you also see, I'm not zoomed in right now, but you also see those squiggly lines. So those squiggly lines represent PWM, and we covered this when we were doing the RGB fading thing. If you want to do half speed, or you want to, more specifically, you want to use the analog right command, you have to use a pin that has a squiggly line. And so what you guys have figured out for me, right, in noticing what's going on, is that we see pin 11 and pin 10 are on squiggly line, or PWM pins, but 12 and 8 are not. So the method that I showed you in doing the half speed using analog right wouldn't work when we are working with pins number 8 and pin number 12. And so that's why. So I just need to apologize. This is a real life class, so real life things happen. Sometimes the teacher is wrong, and we all learn together. Okay, so I hope that you can learn from this as well, right? Because as we build robots, and especially when we do things for the first time, even if you've done things many times, you might make a mistake. And so I want to encourage you as robot builders as well. If you make mistakes, it's okay. We just fix them and we move on. So that's what we're going to do right now. And so let's move down to here, and this is the proposed, and Mr. this to me. This is the new wiring that should fix everything. So let me do that over here. So we have pin motor A is going to be controlled by 9 and 10 because those are both tilde or PWM pins. So let me do that over here. Okay, so 9 and 10. So that's motor A. So just checking here. For me, that is the white and gray. So white and gray. I'm gonna pull these out here. Okay. Sometimes it's going to be easier to pull these out. I got one going crazy. All right. Okay, so for me, it's 9 and 10. There we go. All right, it's moving right now, probably because maybe there's other code on there. I'm not going to worry about that for the second. And then motor B is 3 and 11. That's going to be, for me, these two wires, 3 and 11. Okay, so everything's moving right now. It's going crazy. That's okay. Let's update the code here. All right, let's go to my code. So I had motor B was 3 and 11, so I'm changing these. And motor A was 9 and 10. Right? And then right here it's just going to be empty. So let me just upload this. Oh, actually. Yeah, this should be fine because my loop has no code because I commented out. So it should stop. Okay. And I just realized something now too, because I know that some of you may have had the situation where your motor's moving backwards or is acting weird, and you're not sure what's going on. We just realized here that if our pin modes are not set up, our wheels can be moving when we're not expecting it to. So that's just something to keep in mind. So if your wheels are doing something that's unexpected, make sure you check your pin modes are correct, right? So once we update it to 3 and 11, 9 and 10, it worked. Okay. Now that we have that and we have some background on how to do all this, let's go ahead and make some new functions. And what I want to do, the goal is I want to be able to create a function that helps my robot move forward and also moves backwards, but also not just that, I want to be able to set the speed in that same function. Okay, so we've done some other functions in the past where we just move one motor back and forth, but what I want to do is control both motors to move forward or both motors to move backwards, and I want to control the speed. So the first thing is let's make a function to move both motors forward. So I'm just going to get rid of this stuff for now. Okay. So we're kind of starting fresh. All right. Now that we learned some of the basics, all right. So all I have now is set up motor B pin mode and set up for motor A pin mode. I'm going to get rid of this stuff. Okay. All right. Now let's write a function for void move forward. I'll do that. Okay. Move forward. So how do I move forward? Well, I need to move motor A and motor B. So I'm going to do analog right. I'm just going to use analog right now because I want to be able to control the speed later. So analog right, I'll put a comment here. This will be motor A, and then this will be motor B. Okay. And I'm going to go a little bit advanced now because this is not our first day, and we've done some of this stuff before. So what I want to actually do now, let's use a variable for the pin numbers so that we don't have to keep writing them out. All right. So let's do that here. So the pin numbers for motor B, so I'm going to say int. Okay. And I'm just going to call it B. Let's see. MOT pin 1. MOT B underscore pin 1. And that's going to be equal to 3. And we're going to have another one, MOT B pin 2 is going to be 11. You see that? So that these are the two pins for motor B. So I'm going to, that's pin 1. And then this one is pin 2. The reason I want to do this because if we don't, we have to write 3 and 11 all over again many times as we write our functions. But now we can just use these variable names. Okay, let's do the same thing for motor A, int MOT A underscore pin 1 equals 9. Int MOTA underscore pin 2 is 10. And then we're gonna do this. You might be curious, why am I using the underscore here? It's just something, it seems that it seems better for me as my variable name gets longer and longer. Sometimes I like to put an underscore just to kind of separate it out so it's easier to read. Imagine it was like this, it's like, you know, it's harder to read, so I just add an underscore. And that's a common thing in variable naming. Okay, just a little tidbit for you. Okay, so now I have my variables for the pins, right? And now I can just say, all right, so motor A, let's move motor A forward. So I'm going to say MOT A pin 1, comma 255. Okay, so I want to move it max speed, analog right, MOT A pin 2, 0. Remember, they need to be opposite, right? In order to move. Okay, motor B, let's do this. Analog right, MOT B, pin 1, 255. Analog right, MOT B, comma, pin 2, 0. Okay. Now, just being honest with you, and then as you're doing this, you might be thinking, like, how do I know that 255 should be here and 0 here rather than it being flipped? I actually don't know, so I'm just gonna try this first, and then if any of the wheels are flipped, then I'll just flip the numbers so that it goes the right way. All right, so I'm gonna upload this. Maybe I'll get lucky and both wheels move forward. If not, I'll know how to fix it, right? We just like flip the 255 and 0. So let me upload this and see if it moves forward. Let's see. Oh, you know what? I just realized. We created the function, but what are we missing? We forgot to call it in the loop. That's the main loop, right? We have to say move forward inside the loop. Okay, go. Okay, so you won't be able to tell probably in the camera view, but this motor right here is moving forward, so that's fine. But this one right here is moving backwards, so let's fix that. So which motor is this? This is motor B. So my motor B right here is moving backwards, so we need to flip that. So motor B, it should be 0 here and 255. Cool. Okay, this one's forward. This one is also forward. Okay, cool. So I have a move forward and it's going at full speed. I said I would, you know, change the speed and stuff later, but we'll do that in a second, okay? So first we just want to get that working. That's cool. Let's go ahead then and add the button thing. So that it only moves when we do the button. So for the button, we see pin mode. And since we're doing all this pin stuff, let's say create a variable in button pin equals what? I believe it's 2. Yes, 2. So button pin, and that's going to be an input pull up, remember? Now in our loop, we can say if digital read button pin equals low, because when we press the button it's low, then I want to move forward. Else, let's write something to stop. So we need to make a stop function. Void stop. That will be these guys, right? Except to stop, we just put them all at 255. We should stop. Okay, so let's see if that works. So if I press the button, it should move forward. If it's not pressed, it should stop. Here we go. Make sure you can see here. Let's get my button here. Okay, push the button. Moving forward. Okay, so things are looking good. Now let's do a move backwards. Copy this because it's going to be very similar, right? Now what do I need to do to make it move backward? We just flip everything. So this is 255, this will be 0, and this one will be 255. Order B will be 255 up here, and then 0. Okay, and that's it. So once you do the forward, the backward's super easy. So we have move forward. Let's do a little program here. We're going to move forward, then we're going to do that for a second. Then we're going to move backward for a second. Okay, so go forward, delay, backward, delay. All right, so our code is kind of building up now. It's looking clean, right? And then we'll add the speed change in a second. Okay, so push. It worked. Forward. Okay, everything is good. All right. So we have very clean code, right? We have these nice variables here, so we don't have to keep writing 3, 11, 9, 10 all over and over again. And we have a stop, we have a move forward, we have a move backward. Okay, that's cool. Now, I mentioned the speed thing. So how do we set the speed? Okay, so what we're gonna do is we're gonna add a input into our function. So what I mean by that, so I'm gonna look at move forward, I'm gonna say int inside the parentheses, int speed. So what's gonna happen is you can call the move forward function, but then you can put a speed in there, and then it will move at a certain speed. So it's super convenient, I think. Okay, so right now we use 255, right? Because that was at full speed. But instead of 255, I'm going to use the variable speed and speed. Okay, so if I said move forward 255, and I make speed 255, then it will put 255 here, sorry, 255 here, and 255 here. If I said move forward 100 for speed, it would say 100 here and 100 here. So with one function, you can do any speed now while moving forward. Make sense? Yeah? Okay, so let's try that. So I'm gonna get rid of this for now and just test the move forward. Now you see I said move forward and I don't have anything in there, right? I think I should get an error. Let's see. Yep, it says error, too few arguments to function void move forward. And it has a little arrow here, right? So what that means, too few arguments. An argument is the way that they talk about variables inside functions. So it's like it's saying you have too few variables, because move forward requires an int, but right here you did not put the int in. So it's saying you're missing a variable, or for a function they call variables arguments. So it's nice that it catches that error for you. So now that you've changed it here, we added this argument. Let's go ahead and put it in here. So what speed do I want? Let's say 150. Okay, so if I do that, it should move forward at 150, a little bit slower. Let's see. Yes. It is slower. Let's go 100. It's slower. I wonder if I do 50. It's just buzzing. It's not enough power at 50. Okay, so that's cool. So what we can do now is, we know that that works. Let's do the same thing with move backwards. So move backwards will also have an int speed, and we're going to change the speed of that. Change that to speed, and then change this to speed. So motor B or move backward will work in the same way. So I'm not going to test that. Pretty sure it's going to work in the same way, where you can say move backward and whatever speed. Okay, so that's kind of nice. So now what you can do is change the speed. So I'm going to go a little advanced right now, like if you remember the for loops and how to make loops. So I'm going to just do something for fun right now. Int equals I'm going to create an I variable, 255, which is the max, and then I is greater than 0, and then I minus minus. Okay, what is this? This is a for loop. It's going to have a variable I that starts at 255, and because it says I is minus minus, it's going to keep subtracting in this loop every time that it processes. In this loop, it's going to be 255, 254, 253, 252, all the way down to the 1, because 1 is, this is the condition that it waits for. Okay, so as long as it's I is greater than 0, it will keep looping. Now, why do I want to loop from 255 to 1? Because I want to put something in here. I'm going to say move forward I. I want you to think about that. What is going on here? So what's going to happen is that it's going to start at full speed forward and then slowly slow down. Or not slowly, so it depends how fast this is looping, right? But it's gonna move forward at 255 and then loop through, and then move forward at 254 and then 253 and then all the way down to 1. Now I can put a little delay in here, like let's say 100 milliseconds, right? So now it's gonna move forward at 255 for 100 milliseconds and then loop through, and then move forward at 254 at 100 milliseconds, and then so forth. So I just wonder what we're gonna get here. And so let's try. Okay, I'm gonna press my button to make it go and see what happens. You can hear it. Do you hear it slowing down? Pretty cool. I'm gonna put that as a challenge. Okay, so the first thing is rewire motors to 311 9, and 10. All right, and then number 2 is make functions for forward, backwards, and stop. And then 3 is make functions for forward and backwards that allows you to set speed. And I've already done this for you, so you can just follow exactly what I've done here. Okay? And then number 4 is make your car move and slow down by using the for loop. Right? So exactly what I did here in this for loop here. I think it's kind of interesting. So there might be times where you need to go fast and then slow down. This is how you would do it. And it would be really hard to do this if you didn't have this move forward function where you can just set the speed. Okay? So now that you have that, then I would say there's one last thing, and I would say challenge you guys to do, and we can talk about how to do it, is number 5 is change forward and backward functions so that you can set the speed for both motors. Okay, so what do I mean by that? So right now, move forward, it only takes one speed argument. So that means it takes this speed, right, whatever you put here, and it gives it to motor A, and it also gives it to motor B. But what we've noticed is that sometimes one motor moves faster than the other, so you actually don't want to give them the same speed. Like, what if you want motor A to be a certain speed and motor B to be a different speed? So how do you need to change move forward so that you can do that? My hint is that you're going to need 2 arguments. Okay? Now, have we done 2 arguments? Maybe in the previous semester, possibly, I'm thinking. If not, you can try to look it up. If not, you can try to guess. Like, how do you put 2 arguments into a function? Okay, and remember, if you change it here in making 2 arguments, you also need a update when you call it, right? Then you would have to update right here too if you had 2 arguments, because it only has 1 argument here. It always has to match when you call it. Okay, so that's a little bit of a challenge, but I think it's something that will be good for you guys to tackle. Okay, so a move forwards and backwards functions so that you can set the speed for both motors. Okay, and then once you finish that, create function to turn right. So I'll name it for you. The function will be called turnRight. And turnLeft. So what it will look like, it would be like this: void turnRight, void turnLeft. Okay, so what do you put in there for those functions? Now, what speed for those? It doesn't matter the speed, I would say, for now. You can turn right or turn left at whatever speed. But what we want to do is make sure you turn 90 degrees. Okay, so looking at it, it's like this. If I did the turn left, it would go like this and end up exactly like that. Okay, all right, turn right and turn left. So those are the challenges. Give it a shot. If you need help, I will be be here later this week as we talk. So hopefully that was helpful and interesting. Have fun with that. Talk to you guys soon. Bye bye.